Stojący przed Państwem Michał Giergielewicz opowie nam teraz co nieco o generalizacji. Nowoczesne style architektoniczne często wydają się zbyt skomplikowane. Mają niesłychanie wiele zasad, wywierają presję na kod i zmuszają do dodawania warstw abstrakcji w miejscach, które do tego nie pasują. I jeszcze, żeby tego wszystkiego było mało, arcytrudno je wytłumaczyć. A przecież wiemy, że ważąc w kotle projektu PHP, często nie mamy czasu na wysoki poziom abstrakcji. Jest robota do zrobienia tu i teraz. Jeśli nam się to uda, odkryjemy uniwersalne prawdy o architekturze, czyli wzniesiemy się na wyższy poziom. A przecież to cel sam w sobie. Michale, przedstaw nam zatem tę legendę o świętym Gralu.
Thank you. Sorry, first quick word of explanation. When I placed this talk many months ago, I chose English because I was just asked by Darek that it would be nice to have some talks in English. And only after that, I realized that that means that this speech will be by generated AI voice in English, not by this guy. But fortunately for me, there were some technical difficulties and this English version was not playing correctly. That's why you heard the Polish version. And that's win-win for me. Maybe not for organizers, but for me, yes. Thank you again for coming here. I will be talking about architecture, of course. And first, I want to ask you a question. Of course, if my pilot will work, yeah. Do you know what is cargo cults? Do you heard that term before? Oh, that's interesting. It's actually quite old idea. It was discovered and named like in the late 30s, I think. But the most prominent example of that behavior was after the World War II. And basically, during the World War, on the Second World War, on the Pacific Islands, that was inhabited by a local population of islanders, very primitive tribes, basically. There were created temporary bases, military bases by US military. They just came there for the Pacific area of war. And they, of course, contact those local population. And they give them some gifts, some clothing, some tools, and food and stuff like that. And after the war, they left. And a couple of years later, anthropologists came to those islands, mostly Vanuatu and Papua New Guinea and those areas, and discovered something like that. Those structures were built by those tribes members. And they discovered that they did that because they want to bring the spirits back, their gods, because those gods have cargo. Like miraculous tools with hard iron that was never like dull and stuff like that. Great food, great stuff. And they were with them for a couple of years, and after they disappeared, maybe we did something wrong. Maybe if we do the same thing that we observe during that time, maybe we will get the same results. Maybe the cargo will be back again. And of course, it's a nice story, quite interesting story. Yeah, but why am I telling you this? Why the cargo cults? What does have to do with architecture? And their answer is that I feel that sometimes we do it too. Sometimes we engage in some rituals we do not fully understand, and hoping that maybe we will get some cargo, some results, some benefits. And often, like in the examples of those tribes, we will never really actually get those cargo again, because those planes were fake, of course. And I came across that idea. I just remembered that when I was thinking about what I heard from my colleagues, my people I work with in many different companies, that was conflicting with my understanding about architectures. You know, modern architectures like hexagonal, clean onion, and stuff like that, layer architectures, multiple of them. they are regarded, I think you can agree on that, as quite successful, beneficial, good stuff, what we like to do, because they make our code better and cleaner and simpler and easier to test and all of those things. And we have many books on that, many different talks on different conferences, YouTube videos, you name it. But on the other hand, I have like horror stories. Probably you also have those. Like, we did that hexagonal thing, and then everything is crap, suddenly, or worse than it was before, because probably before it was also not so great. But somehow, from one side, we have like, yeah, architectures are great, but from the other side, no, architecture are actually crap, and we don't want to use them because they make our code worse. And how this can be. And I remember that concept about cargo cults and thinking that maybe there is something into that. Maybe we do something in this manner. Maybe we do some rituals, hoping for the best, without truly realizing what we are doing and why we are doing that. What is the goal? And I want to take you to the journey with me about how I was thinking and trying to understand this deeper level of understanding of architectural concepts in order to make maybe better decisions in the future. Okay. The first premise is that I actually believe, and I will show you, I hope, and convince you that most architectures are actually similar to each other. They use different naming conventions, they use different phrasing and different rules, but the effect that they're hoping to get from that is quite similar to each other, with those architectures either aiming for the same goal. Different path maybe, but the goal is the same. And instead of like focusing on one single architecture, I started to generalizing those. I looked on all of those and tried to find the common parts in those. And maybe those commonalities will give me some deeper understanding about what is actually truly going on. And I will be talking mostly about these three. Of course, there are many different variations of layered architecture, because those three are truly versions of layered architectures. The concepts are the same, only, as I said before, the convention namings and stuff like that are different. And let's look into them. And what is most striking when you start reading about how they work and what rules they give you, there is one concept that is like the most important one in all of those. And they try to find a nice pattern to like encapsulate all of the different naming conventions, and this is why it came about. It's like domain or business and logic and rules, like combine, permutate any pair with each other, and you get some variation that is matching naming convention in some architecture. All of those have business rules, domain processes, business logic, like domain rules, whatever you want to call it. All of those architectures actually have that concept. They name it differently, of course, but the concept is the same. There is a magical part of your code that is somehow special. Of course, there are different parts also, different layers, but this part is like unique. Okay? Hexagonal have core, and the whole word core is like important. And of course, in the diagram, the famous diagram with hexagon shape, which meant that nobody is ever called that architecture ports and adapters, even if this is actually the true and valid name. And even if there is a new book from Alista Coburn, like I think from May this year, which revisited the architecture itself and make a couple of adjustments. And in the first chapter, he like states that this was always ports and adapters, but somehow the hexagonal part stuck. And even that he states that in this book is called Hexagonal Architecture. On the big title on the front, only small print underneath is ports and adapters, that he also understands that must be hexagonal forever. Hexagon have core like clean have entities and bounded and business logic, business rules. Sorry, Onion have business logic. Why this concept is so important? Why these architectures, those architectures like focus so heavily on that? There's multiple of rules what to do with that part, how to communicate with it, how this works, why we want to do that kind of stuff around it to make sure that this part is like kept in secret and special. What is special about it? When we do that, the whole magical things with any architecture to those business rules, we do that separation, we put the code together in separate layer, we do inversion of control stuff, and we remove any dependency, unnecessary dependency from the outside world. We do isolation stuff that nobody, the business logic know nothing about the outside world. And we gain control. We have better control on that code, because now this code is separated, is isolated, is removed of any dependencies. And we have the independence of doing with that code what we want. And of course, there's isolation, and we can do it, especially one thing we can do actually quite much better than without that. And all of those architectures get the same effect from those logics, or from those rules around the logic. But Hexagonal states that very clearly in that, like the first chapter, also first sentence, and even in the old blog post from Ali Stern blog, there is one sentence why he created hexagonal architecture. He did that because he wants to be able to test independently from UI, from databases, and from other infrastructures. Hexagonal architecture is created to do unit testing better. And this separation, isolation, independence, like gives you that. Okay, that, and you can even think about it differently. If you have a magic wand and want to, like, you can just make a wish, and one, but only one part of your code will become simpler, clearer, easy to understand, easy to read, testable. What part do you choose? What part is worth getting that benefits? And of course, it will be my business model, my business logic, my business rules, my use cases. Those are truly important to me, because probably if you make a mistake in that part, it will be high cost associated with that. It's not only like white page on the production, but probably less money in the account or something like that. No, yeah, because imagine that you charge twice for some packet, and then you have complaints, and you need to fight with Visa to not drop your contract, maybe raise your stakes, or maybe you have the same. I have that back in real life. Somebody will give you too low margin on your lease, and you on the good side, but the company, the leasing company, now have a lot less money than they expected, because small error in the code like make that not 2% but 0.2%, and nobody noticed like after a couple of months later. Yeah, those mistakes are truly devastating, can be very devastating, and we want those rules be like ironclad, foolproof, and those benefits we get from these architectures can give us that, because this code will be easier to test, will be independent from each other, but easier to read because it's a lot less dependencies inside. If you imagine, you can have, very often in legacy code, when the architecture is called big ball of mud, probably you're familiar with that, there can be many places, in many different classes, many different layers, even if there is no layers explicitly in the application itself, where there are some small if statements here and there, in controllers, in commands, in repositories, of course also in models, sometimes in views, that do something. They check for something and they change the path of the process. And quite often, those rules do the same if statement, but in many different scenarios. And if you want to find what is the true process, you need to read all of those and find, that is the first part, find all of those if statements. And be sure that you never miss something. It's hard to read. It's hard to find. Do you know that most developers, 80% of their time is spent on reading the code, not writing the code? Yeah. Imagine that you need to read the code because it's so spread out, and so misplaced, that it's actually hard to find. And now you can get the other picture. Somebody shows you a hexagonal architecture or clean architecture, and you can have the promise that all of your rules will be in one single place. That one thing alone can win you. And okay, I will need hexagonal architecture now, because I don't need that spread out search, because everything will be in one place. Easy to read, easy to find. And those are great benefits. It's worth to have that. Yeah, but where's the catch? Because always there's a catch. There's a big but coming ahead. Somebody get that. Of course there is a catch. And of course, every great benefit came with a cost. There is no free lunch in the universe. And if you are willing to do hexagon architecture, or clean architecture, or onion, or something else in similar manner, then there is no free code. They say there is no only moving class in different places. It's not only about the structure. If you want to have that kind of architecture, you need to put a new code in place. That is not business code. This code is only for allowing you to build your architecture. Different interfaces and adapters and strategies and factories, different wiring logic, a lot more complex dependency injection system. There's a lot of the code is only for this architecture to be able to work. And that code is additional complexity. And very often, it is also complex in runtime, because there's no simple call from one class to another. Now there is a 5 different levels of factories and strategies that need to be combined and put into single service that is injected into different services, that is injected into different adapters, and only then it is allowed to call something inside your domain model. And that can be hard. And of course, time-consuming. And of course, it's now more complex to connect the dots, because you isolate your domain model, you put the boundary between it and the rest of the world, but the rest of the world must still be able to talk to your domain model. And of course, you need to find a way to connect everything together. And it's more complex. It's harder to read in general, yeah, because it's much more connections to be made and configuration to pass through and stuff like that. Of course, more abstractions, I told you before. Yeah. There's a lot of interfaces, different interfaces, many interfaces. We love that, of course. And that is probably, I think that this is, I get the complaints the most, that now we have 2 different classes, 2 different places that represent something very similar. And we translate between one and another because they cannot just cross the boundary without any translation. And if we need to send a response back, then this response has also 2 different representations. And translate the response back. And it seems like duplicate code. And we, of course, know that don't repeat yourself, yeah? And it seems like counterintuitive. And yeah, we need to do this cost-benefit calculation. I did the same thing every time I am on the stage. What is the most important part of any architect in a team? To do that, always. Always measure the cost-benefit calculation. Always measure, if we want to choose that path, what we will gain, but what it will cost us. And maybe this cost is too high. Maybe if we're not going that path, we have bigger benefits, but there is a cost way ahead of us. Maybe we can miss it, but maybe we hit. And then we need to do a lot of more work, but how much more? It is like beneficial to us to wait, or maybe we should spend time now. And this seems trivial, of course. Yeah, we always do that. Yeah, but in reality, not so much. We very often act on a hunch. Maybe we are fascinated with architecture, or maybe some design pattern, or some modern word like CQRS, or even sourcing, and okay, go there. It will be good, without actually thinking what it is attached to, because we are focusing very heavily on those benefits parts. Yeah, we will get that, this new shiny thing, but there is a like dark ball of mud underneath that is like connected with a chain, and you just get the both things together. And if you are not realizing that, then there is a surprise at the end that our code is not so great. Or maybe it's better, but we didn't anticipate that part, that messy part that comes with it. And that seems like, okay, we're starting to, this part forced me to realize that there is some truth that I can see now these conflicts between architecture are great, but I have horror stories. Okay, maybe this is something that was causing that, but it not warrant the problem enough. It can be problematic if you choose wrongly and you didn't anticipate the problems, but this should be something more, I think. There's not enough problems to be causing those kind of horror stories. This code should not be so bad, even if you didn't anticipate. Something else must be in play. And this forced me to ask the question, what are architectures for? Because, yeah, most of those just gives you like very specific goals. Hexagonal especially gives you like, okay, you have better unit testing. That's basically it. Remember I don't know if you, probably some of you can remember that like 15 years ago when I think it was 15 years ago, when the hexagonal first came about, that the main focus point was you can switch your database. And most developers went, what? Why? Why do I need that? And it was point of mockery almost. Like, okay, this guy wants to switch database every month. Like, what the hell? Like, come on. But it was purely by not reading the blog post, because there is next sentence after that every developer switch the database many times a day. At least you should do it. Yeah, maybe you do not, but shame on you. Because when you do unit testing, what do? I hope you switch the database. I hope. And this is what hexagonal was built for, to be able to easily switch the database. And other things also, UI, Redis, like file system, whatever, name it. You do not want to do that in your unit test. They should be independent. And this architecture helps you build the code that is independent and can be switched without using 5,000 mocks with add calls from 0 to 5 in every function. Do you have that? Nobody wants to raise a hand. Yeah, that's a hell, because any change in your production code and your test breaks, even if this is pure refactor. Yeah, we don't want that. And architectures can give you very specific like goals, what they are built for. But in general, architecture gives you structure. They give you a set of rules, because architectures are just set of rules and naming conventions. But they are not the design tools. They are about the structure of the code. They are not about the design of the code. And to be more specific, not about the design of your model. But they talk about it. The first slide I showed about domain model, business logic, and stuff like that, this is the most important part for many architectures. They are focused heavily on domain model, but they do not help you build your domain model. If you read in the architecture's descriptions, there's no mention on how to get your domain model. They just assume that you have it. And they probably assume that you have it built correctly. But they do not show you how to do it if you do not have it. And what this can mean for architecture and for your code, that you somehow must do the architecture, implement the architecture. This seems like, sounds weird. It's like implement like agile processes into your company, like do Scrum. Yeah, but you need to know how. Implementing architecture is not like that there is only rules, but you need to apply it in the proper places. You need to make your separation in a proper place. You need to create a boundary around your model. But where is your model? Maybe we have more than one model. Do you know it? Model is not reality. Yeah? We work with softwares, and software is representation of some real-world business process. And this business process is a reality. And we cannot make it like one-to-one. There's always approximation. We create a model of that reality and put it into code. And we need to know which part of this business process is important and connected to which other part of this business process. Is there any distinction and a separation? There is cohesion between some cases. Maybe there is less cohesion between different cases. And very often we end up with something like that. We have here this, oh, sorry. Can this work? I think not. No. Sorry, technical difficulties today. We have this red bounded context. Oh shit, I should do that later. The boundary, sorry, red boundary. This is our business model. Yeah, because we have some maybe folder in our folder structure that is named model or maybe models, and we have that. And there are some business rules, but we do not know that there is a part of the code outside this bubble that is also domain model. Maybe some simple business rule, maybe some simple process that happens to be is not in the same folder. But we implement that hexagonal architecture and we put the boundary around this folder models. And now there is a layer between one model and the same model, but in different place. And we, of course, because this is the same model, we call each other every time. Okay? It's supposed to happen. That's why you create a boundary around the model, because inside the boundary there is no translation and boundaries. You can talk to each other directly. But here there is a translation, abstractions. There is a multiple different DTOs that coming and going. Services with strategies that can be injected and must be injected and converted and adapted and stuff like that. And suddenly it should be simple, but somehow we cannot unit test that because we have that abstraction, this one dependency outside that cannot be mock, because then we will test the mock itself. And that's not supposed to happen. Yeah? Can you see that? Do you see that in the code, maybe? You can have also other things, like maybe you have two bounded contexts. Sorry, the same word again. Two boundaries. The red one and the gray one. But you think that those are separated, two distinct bounded contexts, boundaries, cores. But somehow you put something from the gray one into the red one. Like you misplace the boundary. It's too far gone and catches one of the services. And now you call from red to red, and suddenly there is a gray barrier between. And the same thing, again, translations, abstractions, services, adapters, you name it. And you still need to deal with that complexity. And it should not be necessary, because you think that you are in the same context. But somehow some rule decides that you need to translate everything. You can also have this way. that you created one big boundary, the red one, but inside there are actually two different bounded contexts, two different boundaries, two different domain models. There are no big connections between them. They occasionally talk to each other. Every business logic should, sometimes. But in general, they very closely coupled together, but between them there is only a couple of different connections. But because they are in the same bounded context, the same boundary that you put there, you do not have any translation. You don't have any rules that should force you to do the translation thing. But this time you should do that, because those are different stuff. But you don't not have that kind of policy here because you are in the same folder, then you do not any adapters or services or abstractions. And now you put the coupling because you can couple together classes from the same business logic. They should be coupled. They are here to be coupled. But those two should not be coupled. And now you need to test one, and you notice that very often you need to tag along some service from outside, even if this use case will not use it, but it is in the constructor. Because maybe there is one method in the whole system that actually uses those requirements. But the other 30 or 40 can live without it. And your tests are more complex. You have unnecessary complexity, unnecessary coupling here. And you wonder why. Why those classes are in the same place? They talk only once, but still. Okay? And what this means that very often, and I think this is the true reason why those horror stories exist, very often we are doing one of two things. We have existing application that is mature, legacy, you can call it, and you happen to come across some architecture, and you have some slight problem with your code. It's old. They never built anything with architecture in mind. It's like big ball of mud or maybe something similar to that. And you think, okay, we can put some structure around it. We can like make some cleaning up, put things in proper places. Like it will be small changes beneficially for us. And you read the architecture guidebook, and there are some certain rules that certain things cannot talk with other things, that you need to put classes together in one place and different classes from different layer together. And you start separating the code. And you decide what class goes where on a hunch, because you know the code well. You work on that code for a couple of years. You know what does what, and it just seems reasonable to assume that class with that name can go there. And you build that structure, and like almost always while doing that, you get the first like warning signs that, okay, I can do that, but there is one single exception from my rule there. I need to follow that rule, but if I follow that rule, then probably this use case will be more complex because I need to put some abstraction here. That seems unnecessary probably. But yeah, but the rule is rule. And then you do another use case, and slowly those exceptions are building up. And people start complaining that what before was like direct call now needs 5 different abstractions to call from a single service and then convert into different service and different DTOs. And it seems like unhelpful. But this is okay. We can always think that at the best this is old code. It is hard to do old code to convert that to new architecture. There always will be some hiccups on the way, some bumps, and this is probably it. This is probably that. We can just go through with it, clean everything, and then everybody will be happy because everything will be in proper places. Now in the migration phase, and that migration phase never changes. You are always in the migration phase. Always fighting with the code, always fixing some edge cases, and every edge case requires you to like bend the certain rule, maybe break it. And people start complaining that maybe this is not a good idea. Maybe architectures are bad for you. Yeah? And another case is when you have a greenfield project. You have a greenfield project, small, and there is an empty folder, and you can just start writing. And you just start writing, because we developers like to type, apparently. Carpal tunnel syndrome for the win. And just simple use cases. This is startup. There is not like thousands of different business cases to code. 3 or 4 of them. Just put them in the code because we need to ship tomorrow. And you do that, and it works. And then you do the next 5 and next 5. And after half a year, you have quite a big application. And nobody, at any point, stopped and think about the design in either of those cases. And I think that when I write that, I thought, yeah, but this is obvious. Why put this here? Yeah, because this is obvious. You must have a good design before you use an architecture. Because you need to know where your domain model is, or if you have 3 of them, how they are connected, how coupled they should be, where the boundaries are. And it cannot be done like, oh, I think this class goes here, because the name looks okay. Yeah, we know that fallacy. And architecture are not design tools. They are not for creating your model. They're to structure your model. But we probably all know, I hope, that there are other tools that can give you a good design. And a couple of times I slipped. Yeah, this 3-letter acronym must be here. It's like in all of my talks for the last 5-6 years. And I'm sorry, but I will not stop until everybody understands that domain-driven design is currently, maybe not forever, currently our best tool to model your domain. You could like forget about aggregates and events or value objects or entities or domain services. Forget about it. If you don't want to, don't like it, don't care. This is tactical domain-driven design. I mean strategical domain-driven design. There's bounded context, there are integration between them, and there are tools how to make that model looks good. And what is more important, how to test that your assumption about the model is okay. There is a way to design your code using strategic domain-driven design. And of course, I know blue books are boring. Red books are slightly better, but still boring and hard to understand. But there are other tools, other materials. We have colleagues, even from our community, who do the great job explaining domain-driven design. You watch the videos, you listen to podcasts, you know what I'm talking about. Then just use that. Much better than books. A lot of YouTube videos about that. You have event storming. Who know about event storming? Everybody. Yeah, I know. Yeah, but who actually use that technique? Like once a year. Yeah, and 4 people, 5. And once a week? Okay, 1 person. I need to talk to you about that later. Yeah, I'm using that very, very often. Unfortunately, quite often alone, because nobody in my company is willing to do that. It's always, I don't have time. We don't have time. We are very busy making a business. Yeah, it's like driving a car blind. Like, okay, I'm very busy. Yeah, this techniques is great for discovering your domain. Domain-driven design can model what you discovered. This can actually give you information what your software is about, how the connections look like, What's actually business needs here? And you can do that workshop in like 5 hours, 4 if your software is small, free. Like 3 hours of time. How many meetings a week would that take for average of you? Like probably 3 days and 3 hours can be saved. Like don't go there, do one workshop. Domain modeling. Also, great books, great YouTube videos, how to model your domain. Context mapping. How to actually connect the dots between your boundary context. That's actually very beneficial for any business, especially those slightly larger ones, where there's multiple different domains that need to connect it to each other and choose which part goes where. Of course, there's event modeling if you want. If you don't like event storming. Different techniques, same result. And those are the tools for creating your model. And if you got that, then you can choose any architecture you want and check if you want the benefits that this architecture is giving you, because most of them just will tell you that, okay, Hexagon will give you unit testing and separation, and maybe open-close principle will be easy to implement, maybe it'll be easy to refactor. If your code changes very often, yeah, that's maybe clean architecture for you, maybe Onion. You can just pick and choose, like in the menu bar, like choose what do you want. Because you have your domain ready, you build it up, you know what it looks like, you test it, because most of these tools give you heuristic to check if your assumptions are correct or not, and you can just abolish a couple of those rules because you find out that your assumption was actually incorrect, and maybe your model lies different in different place, and you can measure your success rate. And only after you did that, you can implement your architecture to the code. And from this approach goes those great stories, those books, those people who show you how Hexagon architecture or clean architecture is great. They assume that you know about the other stuff, about the design. And they just present the last step of the process. And now you can get your domain code and create a boundary around it, and do inversion of control to remove dependencies and isolate the code from the outside world to be easy testable. But there's 15 steps before. And if you don't do that, then you get the horror stories. Okay. I'll be slowly going to the end. I have 3 slides, I think, left. And I want to tell you about on one last thing that, of course, first create your model, and then, of course, implement it. And you do not must go like full ahead, like all at once. I have an application that was built a very crappy way, but nobody's fault. People just was learning the language during that time and just do that in their own spare time. And it happens to be it was a great idea. Then it launched very successfully. And now this software is under like support from my team, and we do like I think 2-year cycle between like major refactors, because this code was very crappy. And we create the first design like a couple of years ago, and we choose one place, the most critical one, and we fix that. The rest of the application is crap still. And now we are on the, I think, level 3, let's say, like third design, third iteration, 3 different meetings during last 3-4 years when we trying to choose if this design is still accurate. Maybe something changes and now we need to model it differently. If we find any faults in our previous design, and we iterate over it on paper, not the code, and we create new design, new rules for that model. And we do not implement those rules already. We just put it on the paper. There's in the repository. And after some time, we get a bunch of those changes bunch of different concepts. We find better name for some idea that better represent the meaning of it, and now something else in different places is clear for us, and we can refactor that in the future. We can change the design and change the implementation, but we choose not to yet. Maybe we're now on the 5th iteration, and the current design is completely different from the current implementation. But we don't have time or maybe will to do that yet. But if the problem arises that maybe we need to find a bug, or maybe the application will get much high load, maybe will be more traffic, and some problem will emerge that was not there before, we have the design for it. We have a solution. We built that before. And now we do not need to spend additional time thinking about how to change our domain. We already did that. Now we can choose or find if there is a solution in our design that will fix the current problem. And most often than not, it is, or maybe we have something close and can only like slightly adjust it. That you do not need to put already like 2 months of project to create a design and then half a year to refactor. Nobody will do that. Nobody will agree on that, of course. It's stupid. But you can iteratively create your model, slowly, thoughtfully, in your team. Like, especially if you have domain experts, you can just ask for help. Like half-hour meeting, a couple of questions, maybe mail. We have those questions. Maybe meet sometimes, or maybe in the kitchen during the work break, like coffee and stuff like that, and just ask, what is about this process? What is the exception? Why this sometimes doesn't work? And get the info. Do that like hidden event storming session with them. They didn't even realize they be on one, but you actually get the discovery from it. And then slowly build your design, build your model. And after that, you can choose one small part. And there's different techniques for how to implement it. I will not talk about it. You can ask me later on after the meets. But you have like feature flags, branch by abstractions, and no BC breaks, rollouts, many different techniques to test your ideas in practice and check if they actually work or not without disturbing production. And this will be something that business will be probably willing to go for, because they are not risking that you now revolutionize your code and everything breaks. And yeah, and we have like fire in the building. Then do this like adults, like correctly, not willy-nilly. Okay, well, let's go, YOLO, yeah? No. Okay, last slide. I did that yesterday on my workshop, and I'm doing that here. This is not a virus, you can just screen that, it's okay, I promise. I will not get your credit cards and accounts. I go there is a special link, or PHPCon24. If you have any questions, you have maybe some particular problem in your application, your particular edge case, you want to know more about architectures, Dockers, Kubernetes, virtualization, scalable, MQP structures, whatever you want. Just want to know more, want to solve your burning question, just let me know. 5 people that going that first will get the session for free. And with that, thank you. We have time for questions. Do you have any? Then thank you.